You've come across a load of data X words like warehouse, lake, even lakehouse. I'm going to quickly run through what they are. Across an organization, you're going to have a variety of users, each with different data needs. We'll start with data analysts. They work with structured data, which almost always looks like a table, so databases or CSV files, and compute aggregations to produce dashboards and reports. The naive implementation of this will have them directly accessing all the sources of raw data and handling any cleaning steps like validation, deduplication, and aggregation themselves. The thing to beat here is doing it all in Excel, of course, but as we all know, at any type of scale, that quickly becomes unwieldy. So, the first improvement we can make here is to introduce a data warehouse, which is a centralized store of clean, structured data. Your new single source. This is where everyone should go for their data, not the source systems. This is a very common thing to want to do. So we typically use a managed data warehouse service like BigQuery or Snowflake, given how easy and cheap they make setup and maintenance. So we use ETL tools like Apache Spark or dbt to pull raw data from files and databases and clean it centrally. So now teams aren't maintaining their own views of the same data independently. And now we have a new raw data source. It can be added via ETL. So users only need access to the data warehouse rather than to each data source, which simplifies permission management and reduces time to insight. Next, we'll look at machine learning researchers. They're interested in raw, totally unprocessed data for training models. And for this, we'll use a data lake. This will be a centralized file store and will act similar to an organization-wide shared drive. A simple choice we tend to use is blob storage, such as S3 or GCS buckets, due to the low cost of storing large volumes of data. Data lakes don't require a schema, which allows data to be ingested quickly, and again, reduces time to insight. This is especially helpful in use cases that work on native formats, such as ML, because files don't need to be passed into and out of a database schema. As well as the raw structured data, they're going to want raw semi-structured data, which isn't tabular, but still has some structure, such as JSON, and also unstructured data, such as images. Now, we see there's an opportunity available here. The raw structured data is in our lake, so we can actually populate our warehouse via an ETL from our lake and decouple it from the sources. This lets us reload our data via ETL without putting any load on the source. In fact, in our work for Moorfields Eye Hospital, the raw sources were live clinical systems, which we could only access out of hours to prevent patient impact. So this approach substantially accelerated development. And now that we have the ETL, we can also use it to parse the semi-structured data and make that available to the data analysts from the data warehouse as well. So we now have a standard two-tiered data architecture. One issue here is that we're keeping 2 copies of our data, and they're out of sync. The warehouse always lags behind the lake. If we could bring this all together into one centralized data store, then we could avoid duplication and have easier maintenance and data governance. So, we can replace our 2-tiered model with one data lakehouse. You can still use cheap blob storage, still parse semi-structured data, and still have high-performance querying. This is brought together by the metadata layer. Options include Apache Iceberg or Delta Lake, which defines the schemas for parsing. This is the architecture we built for Moorfields, because we ingest from lots of changing sources and we export data sets based on a fixed point in time. the ability to keep the imported data from previous dates cheaply in GCS buckets combined with Google BigLake means that if we ever need to look back at the state of the data, say, 3 months ago, we can export data as though it were the day we produced the data set. Now, if we look at our architecture, we have all our data coming into the data lakehouse, being parsed in its metadata layer, and being accessed by all users in the same location.